All right, welcome back to part two of the natural selection lecture of the five fingers of evolution. Again, right after this is the quiz. Um, so you should have just gotten done by doing your peppered moth activity. If you haven't done the peppered moth activity, please go back and do that. This will make so much more sense, and you'll be so much more successful on the quiz and the test if you've done that activity, and it doesn't take very long. Directional selection is one of the types of natural selection. This is when natural selection prefers an extreme. So whether things need to be much taller or much shorter, and one of the best examples is the peppered moth. It's the classic example. It was one of the first examples of natural selection that we could measure. And so that becomes really, really important in the history of evolution, and also one of the most generic examples of an ongoing study that proves and validates the theory of evolution. Um, so in this case, directional selection is going towards an extreme. So in this case, frogs' tongues, really long frogs' tongues are more successful than short frogs' tongues. So these are the frogs that are going to get the most resources. They're going to be the most successful and pass their genes on to the next generation. And so you can see the next generation has now an average of longer tongues because these have been eliminated, and it's shifted the whole graph over towards longer and longer tongues. And that's what you saw in the peppered moths with the colors. It's populations were shifting one direction to the other, either over to the white variant or over to the dark variant. Another example is stabilizing selection. So, stabilizing selection is the idea that there's a medium range for this trait that is most advantageous. So, you don't want to be out here on the extremes. The extremes always get eliminated, and the middle is where most of the resources going. One good example of that is human birth weight. There's a weight that allows you to have, if you're too small, you have problems with having malformations and birth defects because you haven't fully formed your organs, or your organs aren't fully functional yet. So there's a lot of problems with low birth weight babies. And to the other side, large birth weight babies have a lot of problems dealing with their mothers during birth. And if it wasn't for modern medicine, there would be really big issues with that. And so again, without modern medicine, you can understand how those extremes of birth weight, really low and really high, would be eliminated, and there would be this birth weight that would be more and more centralized towards a more and more common birth weight. Um, Distributive selection is a really interesting one. This is when there's two extremes that get favored, and the middle is where they lose all of the advantages. So this is either there be a bird beaks is one of the good examples. Is either if you have a population and there's two types of foods that they eat, you will see this population diverge into either small beaks, and let's say that those are small beaks that are eating like small insects, and then large beaks that are eating things like nuts and seeds that need to be cracked by a larger bill. And so you'll see this diverging of this population into two distinct areas. And this is how we normally see speciation: is this mean and this mean will both end up eventually becoming two separate and isolated populations that will eventually turn into two new species. And again, this doesn't have to be a physical characteristic. Disruptive selection also can happen with hunting times. Like nocturnal animals came because some animals were being more successful starting in the morning and hunting into the day, and then resting in the evening and night. And other animals were of the same species, of the same population, were being successful hunting at night, in the evening into the night. And so you can see how those two are both very successful. They're more successful than people hunting in the middle of the day, and more successful than people hunting in the middle of the night. And so those two populations become separated from each other and start to build up differences and differences and differences until the point that they become two separate species. One species hunting in the morning and one species hunting in the evening. And those two populations don't ever cross over. There's no gene flow. There's nothing to stop them from becoming two different species. Okay, so disruptive selection is one of the main types of selection we look for because it causes speciation. The entire population can split in half and become two unique species. All right, so just something to look for. Make sure you get this pass off done, and don't be afraid to go back and retake these pass offs to get